This flashlight, or torch, depending on where you live, was brought in last week with the words, "Flashlight was left out in the rain, it doesn't work now. Can it be fixed?" In this video, I'll show you exactly what part goes wrong inside the flashlight when it doesn't work. What most people do first to diagnose a flashlight is to find its light switch and press it. Now this step, especially by some males, might be repeated even dozens of times. The theory behind is that more is better. But as a repair technique, this makes no difference usually whatsoever. The next thing most people do is tap the flashlight gently. This tapping may actually help restore electrical contact inside the electrical parts temporarily, but is usually not a permanent fix. For some people, hitting a flashlight or hitting things is their top repair technique. Now, some people, again especially males, just try harder, that must work. So beating the flashlight is the next step, but usually that doesn't make it work either. So this specimen here couldn't be made work this traditional ways. So this light actually had to be taken apart, where actual attention to small parts need to be paid and actual observations be made is necessary. So the light did not come apart easily. You can see these tool marks on it here and here. It came apart with a pipe wrench. That's usually bad. It's a bad sign when you need a pipe wrench on a flashlight. And what was inside was horrifying. This is what came out from the flashlight. This is some iron dust that came out from inside, and those are the 4 batteries that were inside. So these not only rusted in the rain, but they also leaked out. So we have the combined effect of both of these things on the electrical parts. Now, one note here, this battery says carbon zinc. The last time carbon zinc batteries were sold to the public was 1992 in North America, roughly. So that rain must have been a big one. Well, anyhow, that was the story I was given. So it was rain. For sure it's rusty, but it also leaked out. This is also why I have this digital clock here. The movement on the clock here suffered a similar fate. The battery leaked out, and it affects the electrical components. Other than leaving a deposit on plastic parts and electrical parts, I'll show you how corroding batteries and leaking batteries affect the electrical operation of the flashlight. So inside this tube, the flashlight parts are just fitted inside a tube. This tube is just a plain pipe. It gets threaded at the end, threaded at the front. This gets fitted on it, and the switch and the light bulb get fitted inside just a plain tube like this. Oh, by the way, a new flashlight is $25. Okay, maybe $35, of the same kind with an incandescent bulb that this one had, and 4 batteries that are size D. Alright, over here on the tray I've got the functioning parts of the flashlight. So here on the tray I have all the electrical components of the flashlight. Taken apart like this, I can test the components one at a time to isolate which one of these components is the actual faulty component. Much more productive than hitting and beating. So testing will be done under power through these electrodes here in my hand. They take power from the DC power supply unit over there in the corner. I've selected 1.5 volts on it, which isn't much. It makes a really dim flashlight, but it's enough to troubleshoot the parts. Even though normally from the 4 fresh batteries you have 6 volts going through all of the electrical components. So testing starts at the light bulb. On the light bulb you have 2 electrical contact surfaces. One of them is this sheet metal surface that sometimes is threaded, not this time, and has this flange on it. This is called the base. The other electrical contact surface is this lump of metal called foot contact. The foot contact and the base are insulated away from each other by this black shiny plastic. So there is no conducting electricity between foot contact and base. So what you do, and you can do this with a battery and a piece of wire, is check how the light bulb works by energizing the light bulb. So one contact goes to the base, one contact goes to the foot contact, and there the light bulb is powered, the light bulb is flawless. Now the rest of the electrical component form part of the circuit or part of the electrical path that either lead electricity to the foot contact or lead electricity to the base. This part here is a spring, and there is this cap on this spring. The light bulb, when it's mounted inside this tube, the foot contact is in contact with this cap and this spring. So these can be tested one at a time, held together to see if they actually work. I'm going to show you this principle here with this metal ring, because I can put it down flat so it's not rolling around like so. So that metal ring that gets threaded to this metal tube there is now part of the base, and the foot contact here can be accessed easily there. We've got power in the light bulb. So this idea can be extended here by the next component. They thread together, and this is solid contact this way, and this plastic piece gets inserted here. There you can see the foot contact now is further down there. I'm just going to try to find it with this electrode there, just like so, there, and contact the base. This metal ring and this tube are connected to the base, so there. These components are okay. Next one is this cap and this spring. I can do this one at a time, but I'm just gonna pick up the pace a little bit like so and see what happens when I test these components this way, and no light happens, or not reliably. If I try to find another spot, the threaded hole there is that there on the outside of this tube, then still not power. Maybe pick another coil. You can see we have very little unreliable light bulb action. With a little more compression and in some different angles, it does become a little better there. So that's how this works. So what do we have here? What's wrong with this spring and this cap? Well, structurally nothing wrong with this spring. It's still a very good springy spring that isn't broken, but if you look closely, say from here, you can see that the spring is coated with corrosion products. It doesn't have a nice and even, and especially you can see them on the inside coils, it doesn't have a nice and even metallic finish. It has a somewhat textured and somewhat dulled metallic finish, even more so on the inside of this spring cap. Okay, the outside looks shiny. Whoa, that's fantastic, no problems there. But you can see starting on the sides here that the electrolytic corrosion, the leaking out of the battery, and added together with the rainwater, corroded the metal surface on the inside of this thing. So that's why these two items together, or even separately one at a time, they don't really provide a solid path for electricity, and that's just a plastic cap. So what can you do with these two faulty components? Very straightforward. Pull out your metal polish and remove the corrosion products. Then when you do have good electrical contact and good electrical surfaces, then it's not going to be a problem. So now, do you really have the time and energy to hand polish this spring? Well, that's up to you. If you really need to get that flashlight going and you don't have $25 but have time, and you have 2 green pea sized amount of metal polish, then you might be able to pull this one off. But troubleshooting doesn't start with isolating these two components as semi-reliable and somewhat faulty. Troubleshooting keeps on going because these two components, or those two faulty components, have a third one on them, this plate, this push plate here, that's also textured and looks corroded. And when indeed this assembly is tested yet again, let's find a hole on the on this tube here, and let me just put this push plate back on. There we can see that there is zero chance of the electric path to make it through from one electrode to the other, and the light bulb does never really turn on. So this part is also faulty, okay? It's also corroded, so this needs to be cleaned thoroughly. So what else? So far it's 3 pieces to clean. What else is faulty here? Well, this plate here, or this assembly, lives inside this plastic housing here. This is part of the switch. This plastic is just molded this way, and this flashlight component is mounted inside this plastic assembly there, like so. So this is how the bulb holder components fit together inside this molded plastic. And this is the push plate here that's spring loaded. You can see I'm compressing the spring, and if I hold this electrode on it and keep it under compression and try to get any electricity through the filament there's nothing there because that contact surface there is badly corroded. If I try it from the spring, which is less corroded, sometimes there I have electricity going through the filament in some spots, depending on there, nothing now and something now. So that plate is faulty for sure, and it needs to be cleaned up, not just scraped up, but really made really clean. So this is the part that you see inside the flashlight, because remember, everything is just mounted inside this tube. So this is what you see at the end of the tube, and this is how the light bulb is being changed by turning the thread on this ring. So far it's 3 faulty components, but that's not the end of it. The batteries, I'm just gonna grab one specimen here, are inside this tube here, all 4 of them, and they contact this plastic in this position, but there is a spring here on this side. Now this spring doesn't want to stay there anymore. I ripped it out, and there's 2 reasons for it. So the spring needs to be conductive enough, but the reason why I ripped it out is because so you can see this deposit there on the plastic. So this is gonna stop any electricity from going through. There also used to be a contact surface here, right here where you see this hole. That plate is what this spring used to be mounted on. Not anymore. This was just held in place by the deposited corrosion products. So one push plate there is missing from this thing. It completely rotted away. Now you might want to replace this, so you need a new part here. You might be able to bypass this by jamming this hole here full with some aluminum foil, baking foil, that you fold up carefully, that it creates a flat enough contact surface here on this side, because the switch, this blue plastic and other components, bridge the gap between this contact surface here and the other one that goes through here. Alright, so that's 1 component here replaced so far, and 3 of them cleaned. Yeah, you might also want to clean this spring when you're at it. So that's 4 pieces to clean. Now on inside the switch, and this blue part fits somehow, yeah, like so. So together with this piece, between this contact surface and nut push plate there at the end of the spring, the switch bridges through these contact surfaces. You can see that this is also springy and it comes out from the switch. Okay, so electricity has this path through from here through that metal to the inside, and something has to bridge from here to here, and from this metal clip here through the whole V shape and to this side. You can see that this side here still has this deposited corrosion products on it, because that was in contact where the corroded away push plate was, or used to be, in contact with this spring. So this is how these two were. Now what's connecting these two V-shaped clips is this metal ring here. The metal ring has a camber to it. It doesn't have a flat surface, it's somewhat domed. Okay, it's not entirely flat. So while you're on your paste to clean those 1, 2, 3 components so far, you might as well clean this ring and that spring and these 2 metal V bars, alright, because guaranteed that these will not conduct electricity reliably without cleaning. And then there is also this part to the switch, which was also mounted inside there through a slot. How do I do this so you can see it through the camera? There, it was going in through there, and it was mounted, that hex nut was mounted there. You get the idea. So all of these metal surfaces need to be cleaned. That's bottom line, and some of them replaced. Now that's not all. There's one more last metal part. At the end of the tube there is this spring. The negative part of the battery is in contact with this spring. Okay, this spring is not conducting electricity either. This is so rusted away that the corrosion products on it make it a complete insulator. This one is flawlessly conducting electricity. I tested it, but the spring is a total insulator now. So I cleaned this spring on a grinder with a wire brush. The wire brush was mounted on a grinder, so that didn't do the trick. So this spring needs to be replaced somehow, or substituted with a big wad of baking foil or something. So for just this video I'm gonna clean all of the metal contact surfaces, all, I don't know, so that was 1, 2, 3, 4, 5, 6 and 7 and 8 metal surfaces. I'm going to replace this one and going to come up with another push plate that goes at the end of this small spring, and I'm going to see if I can indeed make this flashlight work. It's going to be a miracle, I'll tell you that. I'm making good progress, but I'm not cleaning the entire copper pieces, just only the contact surfaces. Here, take a look. Only here, where electricity actually is able to enter the inside of the copper, so any other deposit on it elsewhere is not affecting the flow of electrons. Electrons only need to enter at the contact surfaces. So I cleaned this little rectangular face on it on the outside only, not on the inside, and this angled part as well as the dimple on it. Same on the other piece, and I cleaned this ring as well, only on the outside, not on the inside. So that's how it looks like when it's clean. And just in case you're wondering, the probe is not powered in my hand anymore, and I'll show you how this switch goes together. It's very straightforward. You have these two components that fit together like so. This is the push button that you're pressing, and these ribs on the outside on these two components together will slide into this part here with those ribs. This is how it's assembled, you know, when it's manufactured in China or wherever. So there, when this piece is in, this is gonna be doing the clicking. Alright, that's good there. And then the ring fits on this part there, and the spring goes inside. This spring is going to be sticking out from this like so, but if I provide some spring pressure there, it's doing the clicking flawlessly. And then of course this plate fits in here like so, with this dimply part facing the outside that's gonna be in contact with that spring push plate in there, and then a spring push plate there that I need to manufacture yet. This spring doesn't need to be cleaned because it's not an electrical component. The electrical current is gonna flow from this side here when the switch is on, like so, through this V shape and through the ring in the middle, completely independent of the spring, into this other V-shaped copper clip here. All this fits inside this blue plastic. These two round legs here go there and there, and this square tab and this square tab press down on these copper plates here and hold them in place. So they go together like so. There, spring in the middle. Still clicky and functioning. Very nice. It's still together. Yeah, it's just friction fit like so. Now I can test this three-piece assembly with continuity. So my probes are hooked up to a voltmeter with continuity testing. So when there's a continuous piece of metal, there's an audible sound. Let's see, what have we accomplished here? So when the switch is on, this action moves that ring on the inside to connect this copper plate with this copper plate on the opposite side. So there should be continuity between those two, and there should be an audible sound when I touch the other copper plate there. That's flawless. When the switch is off, of course, no sound is made because the ring is not in the middle anymore. When it's on again, the beep should sound there. Flawless. Okay, cleaning is going so far so good. So you don't have to clean the non-functioning or non-critical parts. I'm making good progress with these parts. Some of these are really easy to clean on a piece of 600 grit sandpaper here that I'm using. Just sandpaper. So I'm only cleaning again the contact surface, so this flat surface as well as the big flat surface on the inside, with a chunk of sandpaper there and the end of the pencil like so between the two of them, like so. Very easy. And yeah, the same applies to this cap here. The inside is clean, not so much the side wall here on the inside, but just the end wall there, because that's how the spring has to conduct electricity to this surface here, not so much to the side wall. Actually the side wall is, remember, it's inside this plastic, so it should be insulated or insulating. So let's see, I've got continuity testing selected on the instrument here. Let's see. So we've got audible alarm there. Let's see how this piece works. Oh yeah, that's flawless. Alright, this will work much better now than in the previous version. So I did not clean the spring coils. It's really not necessary. Electricity needs to flow from here. I only cleaned the end of the spring here. The rest of the coils are irrelevant. Once electricity is able to enter the coil here at the bottom, it needs to exit at the top there. With the rest of them, they don't matter how clean they are. So I just cleaned it like so. Very straightforward. Flawless so far. I also cleaned this part here and bent it, and then it needed a little hammering flat. This one will fit here at the end of the switch, like so, and it goes through, I'll show you, a tiny slot in the switch housing, and the tiny slot is from this side, so the slot is gonna be down there. And let's see, how do we get good light? There you can see that the metal blade is there. I'm just rotating it a little bit. Okay, it fits through there, and it should lie flat against this part here. So that little screw is gonna be mounted there, and that screw is up here, and this is on the underside, lying flat against the this little pipe here. So again, this pipe is connected to this ring, that ring is connected to the light bulb's base. So this part of the circuit here is also important. So I cleaned this surface of the pipe here on the underside, and so both surfaces of this metal, and the end of this bolt here was meticulously cleaned, because this part fits or is in contact with the metal pipe here. If you take a look inside, this head flashlight will help here from the side. This is where the switch gets mounted, and on the underside of the switch you can see that scratch mark right in the middle there, and that scratch mark extends to the left here, and it runs along the entire length of the pipe, because that scratch mark was made when the switch was tapped out. There at the bottom of the there I have it. At the bottom you can see the scratch mark, and it goes through the entire pipe. So that spot on the pipe is also important, that it be conducting well where the scratch mark starts, and when these parts are assembled, then this must be pressed down while this one is fitted into it. Alright, I'll put it together and we'll check for continuity, or we'll light up the light bulb even better. And here is how the parts look like when they're fitted together. This long plate here is between this tubular part of the switch housing. There you can see the end of it sticking out there, and is in contact with the bulb base. That springy push plate there, that contact is gonna take electricity to the foot contact there. So if I'm back to the power source here, there 1.5 volts, and if I hold one probe there and the other one on this part, that light bulb should light up. There, light bulb lights up there. Let me just redo this picture here. There. So, flashlight has been fixed so far. There, I'm pressing on the foot contact and the base, and we've got light. So far so good. What I need to do is fit the switch inside and see how it works with the switch in place. Just give me a sec here. And this is how the parts look like when they are fitted together. This is somewhat friction fit there. And when the switch is on now, electricity must be able to travel through that copper contact surface there, that was that V shape, through the switch, to the other side, to that push plate there, through the spring, to the light bulb's foot contact, out to the base, from that ring to that little pipe, and from that pipe underneath out all the way here to this bolt head. So let's see how this works when I hold the tester there and there. Oh yes, this works flawlessly. Okay, so now we have a functioning flashlight there. All I need to do is come up with something that takes the power from the battery through the spring there. I'm gonna cut something out of copper if I can. I can fit there, and or maybe baking foil. I don't know. I'm just inventing it on the spot here. I'm making good progress here with remanufacturing this contact point for the flashlight. It's going to house this spring. It's gonna be soldered in place. On the other side, I removed the switch body there, but you get the idea. That's the copper contact surface there, and this part on the switch, also springy, is going to be pressing against it. Right now they are just press fitted together. That's important, so they don't fall out of the flashlight when there is no battery in it. And this spring is gonna be soldered in place somewhere there. At the moment this contact point is made of two pieces of metal that are press fit together. This small part here is cut out by tin snips. Let me just focus the camera on it so you can see its edges there. You can see the edges on it, that it's slightly chewed up. That's how tin snips work, okay? And this is a 1 centimeter diameter small copper disc that I made out of a copper pipe that I flattened out, and then you can see my tin snip marks. And this piece is part of this garden hose fitting, and I just hacked the end off it with a saw and then filed it flat. So this is how it looks like. It just happens to fit the recess here in the plastic, because that's important that this be snap fit in place so it doesn't come out when the battery is not in place. So these are gonna be all soldered together into one piece. What got cleaned out from this area here is on this part of the tray. None of it is useful to anybody, but yeah, these are the failed metal chunks that used to be there, and they used to have a shape that I'm trying to make now out of these two pieces combined. So I'll get the soldering gun. So having verified that this part of the assembly is working flawlessly, the last bit to do is this spring. The spring fits into the end cap, and you can twist it out with a little more grunt than this, but it comes out like so. You can see that the last coil on the spring is the least corroded there, and this is how these two were together. On the cap there is the spring seat where the last coil is being placed there, and it's just friction fit like this. It kinda can spring the spring coils like so when it tightens itself into it. So I need to replace this, as this is garbage, but it has to be somewhat similar. I decided to make a spring, and it's gonna have approximately 3 coils at the top 3 coils on the bottom and 3 coils transitioning between the smaller diameter and the bigger diameter. And to this effect I made this on the lathe. You can see that I made the skinny part smaller, so when I wind wire around it, it's gonna be tighter and it can spring to a bigger size, just like so. And the same story repeats with these lower coils, except that this little last coil there is taking up this place, taking up the place, so I can't push it in, but you get the idea here. So that's what this is, and it's got a hole in it. I put a hole in it so I can get the first coil started either at either ends. Okay, so put the wire in and start winding it, handheld or in a vise or with vise grips or whatever. I've got 3 kinds of wire. This is from the welding department. I just went there and asked nicely. You might recognize some of these numbers. These are welding electrodes for some welding there. Let me just steady the image. There are some numbers, 6802. So that's as close as I can get to it. So anyhow, these are welding wires, or about the same diameter as the coil is made out of, but a little skinnier. Not much, but a little skinnier. So I've got stainless steel, I've got aluminum, and I've got copper coated steel. I use this copper coated steel. This is how my finished product looks like. It's a little bit lopsided, but you know, it just does the job. It fits in here kinda tight enough, and then I can kind of force it in, and it's gonna be compressed by the battery anyhow, so it works enough. So with this last setup we can verify that this whole thing works. Let's switch this power supply unit on and select, I don't know, how about 3.2 volts, it just happens to be there. And so this part goes here. Make sure the switch is on. It is on. So, whoop, come back here. So the path of electricity is from that coil through the switch, through the internal components, through the 2 electrodes inside the light bulb, and through the filament, out there on this side, through this long and flat metal piece that's in here, and I'm gonna touch the end of the screw with this spring. Okay, the connection between the end of the screw and the spring is gonna be this tube itself. Alright, so the switch is going in this hole, and you can see a little there, a super tiny hole or a little dimple right there in this tube where this bolt was pressed against. Okay, so it's going there, and the spring is just gonna be inside here. Okay, you get the idea. So that one is powered, this part is powered, and let's see, do we have magic? Let's see. Oh yes, this one works fantastically well. I just kind of push the switch has to be on. Push the switch out of the way a little bit, but there, when good contact is made, you can see the light bulb turns on there. Okay, so this one works. All that's left to do is fit everything back into this tube, and it should still work. I also cleaned this internal snap ring that's inside the tube, somewhat cleaned it on a sandpaper and a piece of float glass. So this snap ring just goes into a groove that's somewhere here inside. Alright, it came out with a pair of not a pair, came out with screwdrivers, so I'm just gonna have to wrestle it back in place just carefully. I don't know how long that's gonna take, but it's going in like so. Eventually it's gonna find its groove and it's gonna snap into it. So I'll show you the finished product in a few minutes. Here you can see the inside of the pipe, and you can see the snap ring just went back into place. I was just finger placing it like so, did not need any tools whatsoever. The front part of this assembly here lies flat against it, so this little recess in this plastic is where the snap ring is gonna go. So that's how this is gonna be in place, and there's something like this just inside the tube, and this front end is gonna hit this snap ring right here. Okay, so that's how the snap ring works, and that's all there is to that. And finally, this is how the finished product looks like. It's fully functional. You can even focus the light there or make a ring out of it, whatever you like. Hey kids, I made you guys a flashlight. Come on in here. Oh, I just made one last change with this switch assembly here. It was taking too much contact force to force it along this pipe here. So, opposite the push button switch here, the ground contact point on this side, touching the inner wall of this pipe here, I wanted to make it shorter, so it's less of a force to move the switch assembly along this pipe. What happened, I wanted to do it with a power grinder, so I put it against the grinding wheel and it flew away, never found it. So what I did is I cut a piece of wire just like this, bent it in a U shape, so that's what I placed inside the remaining hex nut. Now this one isn't in the flashlight because this is too thick of a wire. I found a thinner one that makes a good electrical contact, and it's not taking excessive force to move the switch into place and rotate it if it's out of alignment as well. So kids, come over here. So this is fully functional. Hey kids, I made you guys a flashlight. Take it away. Take a look at this beauty.
Oh, it looks pretty trash.
Does it even work?
Trash.
Oh, well, it works.
No, it's just been, you know, just a little, it's used, that's what it is.
It's pretty heavy and ancient.
Yeah, it's heavy duty, that's the word you're looking for.
It's part of the essentials for any exploring dinosaur.
Yeah, it used to be a police flashlight.
What about this one?
That is my flashlight. It's...
Whoa.
Yeah,
got, like, 3 settings.
Yeah, that's why it's
so
my
cool.
flashlight. Give
Thanks,
it to me.
Dad.
Give it to me! Kids!